The boundary layer is a very thin layer of air lying over the surface of the wing, and for that matter, all other surfaces of the aeroplane. Because air has viscosity, this layer of air tends to adhere to the wing. As the wing moves forward through the air, the boundary layer at first flows smoothly over the streamlined shape of the airfoil. This flow is called the laminar layer. As the boundary layer approaches the center of the wing, it begins to lose speed due to skin friction and it becomes thicker and turbulent. Here it is called the turbulent layer. The point at which the boundary layer changes from laminar to turbulent is called the transition point. Where the boundary layer becomes turbulent, drag due to skin friction is relatively high. As speed increases, the transition point tends to move forward. As the angle of attack increases, the transition point also tends to move forward. With higher angles of attack and further thickening of the boundary layer, the turbulence becomes so great the air breaks away from the surface of the wing. At this point, the lift of the wing is destroyed and a condition known as a stall has occurred. Vortex generators are small airfoil sections usually attached to the upper surface of a wing. They are designed to promote positive laminar airflow over the wing and control surfaces. Usually made of aluminum and installed in a span-wise line or lines, the vortices created by these devices swirl downward, assisting maintenance of the boundary layer of air flowing over the wing. They can also be found on the fuselage and empennage. A chordwise barrier on the upper surface of the wing, called a wing fence or stall fence, is used to halt the span-wise flow of air along the wing. During low-speed flight, this can maintain proper chordwise airflow, reducing the tendency for the wing to stall. Usually made of aluminum, the fence is a fixed structure most common on swept wings, which have a natural span-wise tending boundary airflow. A stall wedge or stall strip is a fixed wedge-shaped strip attached span-wise to the wing leading edge. It is located on the inboard section of the wing at such a point that it causes the boundary airflow to become turbulent as the angle of attack increases to a certain point. This purposeful destruction of the boundary airflow as the angle of attack increases causes the root of the wing to stall first. Thus, airflow over the outboard wing section and over the ailerons is preserved during the stall, making it easier to recover. A wedge can also serve as a stall warning device by invoking turbulence with vibrations, warning the pilot. A few aircraft have a sawtooth leading edge, where rather than being a smooth continuous surface, the leading edge juts out slightly at points determined to be beneficial by design engineers. The purpose of the sawtooth wing is to utilize the vortex created by an inboard section of the wing to improve boundary layer flow over an outboard section. This increases lift and resistance to stall. Sawtooth wing leading edges are most common on high-performance military aircraft. Wingtip vortices are caused by the air beneath the wing, which is at a higher pressure flowing over the wingtip and up toward the top of the wing. The end result is a spiral or vortex that trails behind the wingtip anytime lift is being produced. This vortex is also referred to as wake turbulence and is a significant factor in determining how closely one airplane can follow behind another on approach to land. The wake turbulence of a large airplane can cause a smaller airplane, if it is following too closely, to be thrown out of control. Upwash and downwash refer to the effect an airfoil has on the free airstream. Upwash is the deflection of the oncoming airstream, causing it to flow up and over the wing. Downwash is the downward deflection of the airstream after it has passed over the wing and is leaving the trailing edge. This downward deflection is what creates the action and reaction described under lift and Newton's third law. A winglet is an obvious vertical upturn of the wing's tip, resembling a vertical stabilizer. It is an aerodynamic device designed to reduce the drag created by wingtip vortices in flight. Usually made from aluminum or composite materials, winglets can be designed to optimize performance at a desired speed. They use the flow of air from under the wing to create thrust, thereby reducing induced drag. Significant fuel savings are also achieved.